Hello everyone, it's me, Eddie, and I'm here to show you how to use elimination method by addition or subtraction to solve a system of linear equation. Our first example is two variables. Let's say we have 2x plus 4y equals to 6, and that would be our equation 1. Then we have also 5x minus 4y equals to 8 for our equation 2. To solve this, choose a variable that you want to eliminate. My advice, choose a variable that is easy to eliminate, and also make sure that variable has opposite sign in each equation. In this case, it is the variable y, or the term 4y. In equation 1, as we observe, we have positive 4y, and for the equation 2, we have negative 4y. So they are opposite sign. It would be easy for us to eliminate this variable. Then apply addition. Then 2x plus 5x, that would be 7x. Then add 4y minus 4y, so 0. Then 6 plus 8, that is 14. So we have now our new equation, 7x is equals to 14. To get the value of x, divide both sides by 7. Therefore, x is equals to 2. And solve for y. Just choose either equation 1 or equation 2. Let's say I will choose equation 1. So all we need to do is just substitute the value of x. So we have now 2 times x, which is 2 plus 4y equals to 6. 2 times 2 is 4. Then transpose the 4. So we have now 4y equals to 6 minus 4. Then 6 minus 4, that is 2. Now to get the value of y, we will divide both sides by 4. So we have the value of y equivalent to 1/2. If you want to check your answer, choose again an equation. This time, I will choose equation 2. So we have 5x minus 4y is equals to 8. Basically, the equation tells us that 5x minus 4y should be equivalent to 8. To do that, just substitute the value of x and y. So we have 5 times x, which is 2, minus 4 times y, which is 1/2, then equals 8. 5 times 2, that is 10. Then 4 times 1/2, that is 2. Then 10 minus 2 is equals to 8. Wow! So far, are we learning? If yes, type yes in the comment section. Now let's proceed in the next example. Let's try to eliminate a variable that doesn't have same constant value and are not opposite sign. For example, equation 1, we have 2x plus 3y equals negative 16. Then for equation 2, we have 5x minus 10y equals 30. Here, I want to choose variable x to eliminate. To do that, we need to modify each equation so it would have an x that has same constant value with opposite sign. To do that, let's take the constant value of x in each equation and determine the least common multiple, or the LCM. The least common multiple will become the constant value of variable x in each equation. For equation 1, we have 2. 2 plus 2, we have 4. 4 plus 2, 6. Followed by 8. Then followed by 10. Then for equation 2, we have 5. 5 plus 5, that would be 10. 10 plus 5, 15. Then 20, and then 25. Now, did you see the least common multiple? If yes, type LCM in the comment section. Here the LCM is 10. Now, let's modify each equation so they would have a positive and negative 10x. In equation 1, to make a constant value of positive 10 for variable x, we will multiply the whole equation by 5. And for equation 2, so it would have a constant value of negative 10 for variable x. We'll multiply the whole equation by negative 2. For equation 1, 5 times 2x is equivalent to 10x. Then 5 times 3y, that is 15y. Then negative 16 times 5, that is negative 80. For equation 2, negative 2 times 5x, negative 10x. Then negative 2 times negative 10y, positive 20y. Then 30 times negative 2, negative 60. Then let's add 10x minus 10x, that is 0. 15y plus 20y, that is 35y. Then negative 80 minus 60, negative 140. So now we have a new equation. 35y equals negative 140. To get the value of y, we will divide both sides by 35. Negative 140 over 35, that is equivalent to negative 4. And that is our y. Now, solving for x, I want to choose equation 2. So equation 2, we have 5x minus 10y equals 30. You can choose as well the negative 10x plus 20y equals to negative 60. You will come up with the same answer. Now let's substitute the value of y. So 5x minus 10y, which is equivalent to negative 4, equals to 30. Then negative 10 times negative 4, that is positive 40. Okay, transpose 40. 30 minus 40, that is equivalent to negative 10. Then to get the value of x, let's divide both sides by 5. Therefore, x is equivalent to negative 2. Is this correct? Let's check. Okay, so now I will choose equation 1. So equation 1, we have 2x plus 3y equals to negative 16. Let's substitute the value of x and y. So 2 times x, negative 2, plus 3 times y, negative 4, equals to 16. 2 times negative 2, that is negative 4. Then 3 times negative 4, negative 12. Negative 4 minus 12, that is negative 16. Are we improving? If yes, type yes again in the comment section. Okay, I believe at this moment you learn a lot and you want to learn more. So right now, for our last example, I want you to listen carefully and focus to the process. Let's try 3 equations with 3 unknown variable. Let's say we have 4x plus y minus 2z equals 0. So this will be our equation 1. Then we also have 2x minus 3y plus 3z equals 19 for our equation 2. Then lastly, we have negative 6x minus 2y plus z equals 0 for our equation 3. So we aim to get the value of x, y, and z. To do that, first, choose a common equation that we will use to subtract to the remaining two equations. Then, choose a variable that you want to eliminate. After that, we'll be able to reduce our equation into two with two unknown variables, and we will apply what we learned in the previous two examples. Let's say my common equation is equation 2. Then the variable I want to eliminate is x. So let's subtract equation 1 with equation 2. To eliminate x, let's get the LCM. For the equation 1, we have 4 followed by 8, then 12, 16, and 20. For equation 2, we have 2, 4, 6, 8, and 10. So our LCM will be 4. Since equation 1 has a constant positive 4 already, we don't need to modify the whole equation. But for the equation 2, we need to multiply it with negative 2. Okay, copy equation 1. Then for equation 2, negative 2 times 2, so negative 4x. Negative 2 times negative 3y, we have positive 6y. Negative 2 times 3z, that is negative 6z. Then negative 9 times negative 2, that is negative 18. Then add. So 4x minus 4x, 0. Then for y, we have 7y. Then for z, we have negative 8z. And we have negative 18. Now we have our fourth equation, which is 7y minus 8z equals negative 18. Equation 4. Next, to determine our fifth equation, let's subtract equation 3 with equation 2. So we have 2x minus 3y plus 3z equals to 9. Then negative 6x minus 2y plus z equals 0. Again, get the LCM and eliminate x. For equation 2, we have 2, 4, 6, 8, 10. For equation 3, we have 6, 12, 18, 24, and 30. So the LCM is 6. Since equation 3 has negative 6x already, there's no need to modify this equation. However, let's aim for positive 6x in equation 2. To do that, let's multiply equation 2 by positive 3. So 3 times 2x, that is 6x. Then 3 times negative 3y, we have negative 9y. 3 times 3z, so 9z. Then 3 times 9 is 27. Then copy equation 3. Next, let's add the two equations. So we have 0, then negative 11y, then positive 10z, then bring down 27. Now we have our fifth equation, which is negative 11y plus 10z equals 27. Okay, so now that we have two equations and two unknowns, we can now get the value of the variable y and z. So let's equate equation 4 and equation 5. Let's say I want to eliminate z. So let's look for the LCM. For equation 4, we have 8, then 16, 24, 32, and 40. Then for equation 5, we have 10, 20, 30, 40, and 50. So the LCM is 40. For equation 4, we will multiply it with positive 5. Then for equation 5, multiply with positive 4. As you can see, we don't have a negative multiplier because variable z in each equation already has opposite sign. Okay, so for equation 4, 5 times 7, that is 35y. Then 5 times negative 8, negative 40z. Then 5 times negative 18, that is equivalent to negative 90. For equation 5, 4 times negative 11, we have negative 44y. 4 times 10, 40z. Then 27 times 4, 108. So let's add the two equation. 35y minus 44y, that is negative 9y. Then for z, 0. Then negative 90 plus 180, that is 18. Now we have our new equation, negative 9y equals 18. To get the value of y, divide both sides by negative 9. So y is equivalent to 18 over negative 9 or negative 2. Next, let's solve for the variable z. Let's say we choose equation 5. Equation 5, we have negative 11y plus 10z equals 27. Then substitute the value of y. Negative 11 times negative 2 plus 10z equals 27. Okay, negative 11 times negative 2, we have positive 22. Then transpose the 22. We have 27 minus 22. 27 minus 22 is equivalent to 5. Now divide both sides by 10. We get the value of z equivalent to 1 half. Now, solve for x. Let's just choose from the three original equation. Let's say I choose equation 2. So we have 2x minus 3y plus 3z equals 9. Then substitute the value of y and z. Negative 3 times negative 2, we have positive 6. Then 3 times 1 half, that is 3 halves. Substitute the 6 and 3 halves, so we have 2x is equivalent to 9 minus 6 minus 3 half. And that is equivalent to 3 half. To get the value of x, let's divide both sides by 2 or multiply both sides by 1 half. So we get the value of x equivalent to 3/4. Wow, are we good? So this time we will check our answer. So let's choose equation 1. Equation 1 has 4x plus y minus 2z equals to 0. Then substitute the value of x, y on z. So we have 4 times 3/4 plus y, which is negative 2, minus 2 times z, 1/2. So it should be equivalent to 0. So 4 times 3/4, that is 3. Then we have negative 2. Then 2 times 1/2, that is 1. 3 minus 2 minus 1 is equivalent to 0. And there you go. That's how you solve system of linear equation using elimination by addition or subtraction. But wait, there's more. I want to teach you also how to check your answer using calculator techniques. I made a separate video for that. Just check the description below. That's all for my video. I hope you learned a lot. Please support my channel. Just hit the like button and don't forget to subscribe. If you want to learn more about electrical engineering and mathematics course, just click the bell icon so you would be notified for my new videos. It's me, Eddie. See you again in my next video.